Hey, I'm going to talk about this Roman numeral to integer problem. I solved it with a recursion, which I thought was kind of a creative way to do it. There's also a linear traversal way you can do it. I'm not going to go over that. It's a little faster. But if you want to solve it with recursion, I'm going to go over this algorithm. So the description of the problem, it gives a table of what the integer equivalents are to the Roman numerals. Not of all Roman numerals, because as it states here, you can add them together, and this one section says you can subtract it if it's before the highest Roman numeral. So that kind of gave me intuition on how I ended up doing it, which is I check the left and right values and evaluate them, and then subtract and add them appropriately. So right here it says you can add them if they're to the right of the highest value. So xii or 2 i's would be the same as 10 plus 2, which is 12. And then this one's xvii, which is 10 plus 10, which is 20, plus v, which is 25, plus 2, which is 27. Um, so this part right here states that if it's on the left-hand side, that it can be on the left-hand side, like an IV, which is 4. They don't represent it with 4 i's, they represent it with 1 I before the V, and that represents 4. You can also do this with X as IX, which is 9. And then you can also do this with L and C and place X before it, which is 40 and 90 respectively. And then you can also do this with D and M, place C before it, subtracts 100, and then evaluates to 400 and 900 respectively. And then this is kind of some examples. I don't really want to go over this example or this example because there is no left value for the highest Roman index. So L is the largest one, so it just keeps adding it to the right. So I found this one more interesting. It starts where this is just evaluated and then it goes here. But the interesting thing is when you evaluate this with the algorithm I'm doing, it has a left value. So the next string that would do would be M and then C, and then I would evaluate that. So I'm going to kind of go into how that example would be evaluated using this algorithm here. Um, yeah, so this is what we're evaluating. How it works is it takes the highest one, which is this M, which returns 1,000. Then it takes the left value, which in this case defaults to 0 because there is no left value. And then it calculates this right string, which is this string right here, and it gets 994. But it doesn't do that since it's recursion. It doesn't do that right away until it hits its base case. But that's what it will evaluate at the top level. So the next one is how does it evaluate this string? So it grabs the M, which isn't in the beginning, so there is a left value in this case. So then it separates the left and right values. So it has to calculate C, which is the left value, and this is the base case. So it does 100 plus 0, or 100 minus 0 plus 0 to evaluate C, which is just 100, which is itself. And then it has to evaluate this to get the 94. And what you notice is 1000 plus 100, or minus 100, which is 900, and then you add 94, you end up getting 994. So that's how this is calculated. And this 100 is calculated this way. So that's how that's evaluated. The 94 right here is calculated right here. So it grabs its left and right values and the highest value. Don't forget about that too. So its highest value is 100. X has a base case, which just is 10. And then it calculates the Roman numeral IV. That's not a base case quite yet. It still has to do the left value of I, so it needs to subtract the 1, which is evaluated right here, and the right value of 0, and the base case of I, which is just 1, so that's how this got returned. And then it goes all the way up, so this goes here, this 5 minus whatever, this IV was calculated for this, And then the x, I don't like that left value in there anymore. I thought I got rid of all those. It kind of, yeah, all right. So you can see that the x is evaluated for this xciv is evaluated for this, and this c is evaluated for this, and that's how it gets the return value. And then it finally takes all of these, calculates 994, gets the right value, and then finally takes the 1000 plus the 994, which gets returned last, and then finally calculates 1994. So this is kind of how this algorithm works. Show the code a little bit. I don't think I explained it yet, but this is grabs the highest Roman index, which is essentially where it's located in the string. It takes that index, grabs the character, grabs the integer value of the character, which the one that we were looking at was m, and then it checks the left value. If there is no left value, so if the index is greater than 0, there is a left value. If it's not, then it doesn't evaluate this. And it defaults to 0. Does that same thing, does bounds checking to see if there actually is a right value by checking whether the index is less than the last index available in the string. Grabs the substring and then calculates it. And then it finally returns the most left bound integer max value, or whatever, this part right here, the highest character, as a Roman value. Then it subtracts the left value and then adds the right value. And that's kind of what I was explaining in the text document. So I hope you enjoyed this. This was kind of a interesting algorithm that I came up with that I was happy with. Anyways, take care and keep coding.